Buenas tardes, les habla la profesora Zoraida Almengor, directora del plantel. Les envío un afectuoso saludo en la Semana de la Ciencia. Estoy segura que durante todos estos días celebraremos el conocimiento, la oportunidad de investigar. Desarrollaremos actividades donde pondremos en práctica el cómo, el cuándo, dónde. Encontraremos relaciones entre los acontecimientos. Desarrollaremos explicaciones a los fenómenos. Y sé que con todos estos procedimientos celebraremos la importancia de la ciencia como forma del conocimiento. Que vivamos una excelente semana y que podamos compartir excelentes proyectos. Saludos.
Flow, okay? And size, and that is colors. Look at this. Oh wow! What color is this?
Yellow.
Yeah. What color is that? Excellent. Good job. And that is a shape. What shape is this?
Blue.
What shape is this?
Blue.
What shape is this?
Circle.
Excellent. Circle. And what shape is this? Triangle. Good job. Fantastic. Okay. Big, small, and big. Is the red? What color? What size is the blue? Big. Excellent. Yeah. And that is big or small? Small. Excellent. Okay, look at this. Look. I have, in my pocket, I have a pen, a coin. Do you have a coin? A coin?
No.
Okay, look at this. Okay.
The muffin float. The scissors sink. The the coin sink. The ice cream cone sink, and the paper sink too. Float. The paper float. Bye bye.
A ver cómo va a ser esa foto grupal. Todo el mundo súbanla cómo va a ser esa foto grupal. 1, para ver los planetas. 2, para ver los planetas. Miren todos. Súbelo, Tiago. Y 3. Así los quiero ver. Dele, súbalo. Tíralo ahí. ¡Vamos! Silencio si no lo quito. Vamos, Elizabeth. Ok, vamos, Fabiana. Rapidito. Vamos, Natalie. Vamos, Natalie. Vamos, Sofía. Sofía, vamos. Muy bien, vamos, Abraham. Muy bien, vamos, Ana Cuña. Bien, vamos, Tiago, nos queda el último. Vamos, Tiago, nos queda Marte. ¡Completo!
and friends. Today I create bubbles. We need water, liquid soap, plastic jar, and bubble gum. Put the water here and the liquid soap. We mix in a few hours to have bubbles. And ta-da! Bam! Bubbles! Hello, teacher Leica and classmates. Today's experiment is very interesting, and this is what we need. We need vinegar, baking soda, food coloring to make it fun, a balloon, and a plastic bottle. Step 1. Pour the vinegar in the bottle. Step 2. With a funnel, put the baking soda. Let's put some color. Now cover the bottle with the balloon. Security first. And now prepare yourself to be amazed. Wow! The balloon. I can't believe it. Eureka! That's the magic of science. Good morning, Teacher Eureka. My name is Imari. I am going to present my experiment material. Baking soda, plastic butter, balloon, and vinegar. First, we put the vinegar in the plastic butter. Next, we put the baking soda in the balloon. We put the balloon on the plastic bottle. We put the baking soda. The balloon is filled of air. Thank you.
Hello, teacher. My name is Moshe. I'm going to present the experiment with the baking soda and the vinegar. First, I'm going to put the vinegar in the bottle. Next, I'm going to put the balloon in the bottle. And the baking soda is already in the balloon. And vinegar with baking soda create bubbles and gases. Thank you.
Buenos días, maestros y compañeros. Mi nombre es Lucas Rivera Flores. Clase del cuerpo según la luz. Con la luz se reflejan imágenes en el espejo claramente. En la oscuridad
Good morning, teacher and friends. My name is Primaria Jimenez, and I'm going to present my experiment. How can you make bubbles? The material that I use to make bubbles are water, liquid soap, bubbles one. In my case, use my Barbie bubbles. One container. First, we put the water in the container. Then we put the soap. Mix. We wet our bubble one in the container with water and soap. Finally, we blow our bubble one to see the bubbles. My Barbie bubbles. The experiment Barbie bubbles. The experiments are very funny and teaches us identify the solid, liquids and gases. Thank you.
Hola, mi nombre es Nathan Moreno, pertenezco al segundo C y hoy voy a darles el tema sobre cómo hacer burbujas de jabón. Los ingredientes son 3 tazas de agua, un vaso de vidrio, una taza de jabón líquido, una cuchara y una varita para hacer burbujas. Primero ponemos el agua en el vaso. Después ponemos el jabón líquido en el vaso. Terminamos. Ahora podemos hacer las burbujas. Es muy divertido hacer burbujas.
Good morning, teacher and friends. My name is Ciencias. Today I will show how can we make bubbles. We need water, liquid soap, a jar, and bubble wrap. Okay, I will explain the process. We have to mix the water with the liquid soap. In a plastic jar. Then we have to wait a few hours. After 2 hours, we can make bubbles with the bubble wand. experiments, like soap bubbles. I like it. Thank you.
Buenos días, maestra y compañeros. Mi nombre es Karina. Hoy les voy a hablar sobre la charla del espejo. Okay. Clases de cuerpo según el paso de luz. La luz ilumina y te permite distinguir el objeto, en este caso mi imagen del cuerpo. Sin luz no te permite ver tu cuerpo porque está oscuro. La diferencia es la reducción de la luz. Gracias.
Mi nombre es Vina Yetman. Hoy les voy a presentar el video del poroto. El día 1 el poroto lo pusimos con algodón y agua. Al tercer día el poroto no germinó, pero al día 6 el poroto germinó y tenía unas hojas cerradas. Al día 9 el poroto ya se veía más grande y con unas hojas y un tallo más alto y tenía unas hojas de color verde. Al día 12 el poroto estaba listo y grande con más hojas y estaba listo para ser trasplantado. Hola, mi experiencia con estos porotos fue muy, ya saben, emotiva. Me gustó mucho el experimento. Son como unos porotos que germinan y me gustó mucho ver cómo la planta está empezando a germinar. Con muchas plantitas y cosas muy emotivas. Y me gustó mucho este tema del poroto. Creo que este poroto es más que un solo experimento y me encantó hacer este experimento del poroto, ver cómo cada día el poroto iba creciendo hasta ya verse como este poroto que tenemos aquí en el día 12. Compañeros, mi nombre es Dave Ramírez y hoy les voy a hablar acerca de mi maqueta, ecosistema terrestre, en específico la selva. Es importante cuidar el suelo, flora y fauna porque nos ayuda a preservar la vida humana. Si cortamos árboles y matamos a los animales, poco a poco se va destruyendo el planeta y el medio ambiente. Gracias.
semillas como maracuyá, tomate y pimentón. Esta es mi primera vez que he plantado una semilla de poroto. Como no he podido ver cómo han crecido las otras, porque están debajo de la tierra. Así que me divertí, la pasé bien. Y les recomiendo que planten otros tipos de semillas para ayudar a la naturaleza. Miren que mi planta aún sigue viva. ¡Chao!
Luces, cámara, acción.
Buenas tardes, queridos televidentes. Hoy vamos a hablar sobre el Día Mundial del Reciclaje en Planeta Prado. Hoy vamos a hablarles sobre Isla Prado. En la Isla Prado es un lugar donde hay muchos animales felices, no se corre peligro de animales intoxicados, hay un mar supermente cuidado. Las personas que van a Isla Prado cumplen con las tareas de reciclaje y si no reciclan van a ser multados a 2 meses limpiar lo que intoxicaron y ensuciaron. Es un lugar donde las familias, niños pueden ir con sus seres queridos e amigos a pasar grandes tardes y mañanas. Es un lugar pacífico donde puedes ir con tus familiares y seres queridos. Aquí imágenes. Familia feliz compartiendo una gran vida con los delfines. Los delfines de Isla Prado son muy amigables. La razón porque los cuidan, les dan comida y no sufren de intoxicaciones. Sus medidas de bioseguridad, mascarilla e bolsa reciclable y con tu burbuja familiar. Recuerden no tirar basura en el medio ambiente. Con ustedes reportó Juliet Prado.
Buenos días, maestros y compañeros. Mi nombre es Elisa Samudio y el día de hoy les quiero contar cómo me fue en el experimento del poroto. El primer día agarré un vaso, le puse algodón, puse mi poroto, lo regué y lo dejé al sol. El tercer día, mi poroto le salió una pequeña raíz. El sexto día, mi poroto creció un poquito más. El día 9, mi poroto ya tenía tallo y varias hojas. El día 12, mi poroto siguió creciendo y creciendo. Pero el día 15, mi poroto siguió creciendo, pero se estuvo marchitando un poco. Entonces decidimos plantarlo en un pote con tierra fresca. Y como podemos ver, aquí mi poroto tiene el tallo más grande, tiene varias hojas. Y mi parte favorita de este experimento fue que pude observar cómo mi poroto fue creciendo, desarrollándose, todos los cuidados que necesitaba. Y eso fue lo que me gustó de mi experimento, poder tomar notas y cada día ir viendo cómo mi poroto se desarrollaba e iba creciendo. Gracias.
Hola maestra y compañeros, mi nombre es Nelly Sofía y hoy les voy a hablar del ecosistema de los manglares. Los manglares son un bosque formado por árboles, arbustos, palmeras, helechos y sobre todo, el más importante de todos, el árbol de mangle. De ahí viene el nombre de los manglares.
La fauna de los manglares está formada por crustáceos, peces, moluscos, aves y otros más. Los manglares son importantes porque producen materia orgánica, retienen sedimentos y protegen las zonas costeras de la erosión por el agua y viento y retienen la arena sobre las playas. Son barreras naturales contra vientos y mareas altas, lugar de alimento para aves y lugar de refugio para animales. ¿Cómo protegerlo? Eviten contaminar, no tiren basuras que pongan en riesgo a los animales y no corten los mangles. Aquí pueden ver a mi familia recogiendo la basura para que no se contaminen los mangles. Muchas gracias por ver.
Muy buenos días, maestras y compañeros. Mi nombre es Vina Camarino y hoy les voy a hablar de mi ecosistema elegido. Mi ecosistema elegido es uno mixto, ya que el ecosistema terrestre y el ecosistema acuático. El ecosistema terrestre representa el bosque y el ecosistema acuático representa el río. ¿Por qué hay que cuidar el medio ambiente? Porque es el lugar a donde vivimos. Para poder cuidar a los bosques, podemos plantar árboles, donar libros que ya hemos usado, no desperdiciar papel de baño ni servilletas y por último, reciclar papel y cartón.
Buenos días a todos, maestras y compañeros. Mi nombre es Pilar Aguirre y estoy en el tercer grado D. Hoy les voy a presentar maneras de cómo cuidar el ambiente. ¡Mamá! ¡Alto! Recuerda que hay que reciclar los plásticos. Es importante que todos empecemos a reciclar. ¿Quién habrá dejado la llave abierta? Es importante no malgastar el agua. Tenemos lámparas que se activan con sensores de movimiento para ahorrar luz. Seamos parte de la solución, no de la contaminación. Cuidemos el medio ambiente.
Buenos días, maestros y compañeras. Soy Gabriela Sofía Pinto González. Hoy les voy a decir de mi experimento con los porotos. Bueno, lo que pasó cuando nosotros hicimos el poroto, pasó algo muy triste que yo hice 2 porotos, uno en el día de la clase y el otro antes de la clase. Entonces lo que pasó por descuidarme, no me di cuenta muchos de ellos y ellas se pudrieron, pero ahora hice otro y aquí están creciendo. Ahí están como comenzando a romper su cascarón del poroto. Y aquí también hay otros, pero que más o menos están abriéndose. Entonces me gusta ver cómo rompen el cascarón del poroto. Muchas gracias.
Muy buenos días, maestros y compañeros. Mi nombre es Abigail, del tercero grado C. Yo les voy a presentar la receta. Mi receta es pancakes de banana. Para realizar esta receta necesitaremos una banana entera, una taza de harina, agua al gusto, spray antiadherente, miel de abeja natural y la harina de pancake y para decorar unas ricas cerezas. Sin miedo. Deja una banana. Ya una vez majada, vamos a hacer la masa para el pancake. Vamos a hornear la harina. Vamos a poner todo. recuerden que no le pueden echar toda porque si no luego les va a quedar muy seco o muy húmedo. Vamos a comenzar con un poquito y buscamos nuestra batidora y vamos a revolver. Depende de que si está muy húmedo le tenemos que poner más harina y si está muy seco le tenemos que poner más agua. Cuando ya estén revueltas y un poquito más de agua. ¿Ven? Ya tenemos la textura de la masa. Ahora, les voy a dar un tip. Si quieren y tienen, pueden agregarle colorante alimenticio. La dividen en dos y luego ponen de un color la masa y de otro color. En este caso yo lo voy a hacer para que vean cómo se puede hacer. Yo voy a dividir la masa en dos partes. Cuando ya tengamos la masa dividida, vamos a agregarle los colores. Yo en este caso voy a usar rojo y verde. El rojo y voy a revolver. Y ahora le vamos a colocar 1, 2, 3. Recuerden que es la tonalidad de su agrado. Bueno, ya tenemos la masa lista. Ahora vamos a agregar un tercio de esta masa y le vamos a poner, antes de poner la masa, le vamos a poner el aceite. Luego, como ya lo tengo aquí, voy a verter aquí la masa de panqueque. Les voy a decir un tip genial. ¿Cuándo sabemos que la masa está lista para voltearse? Cuando vemos que en la superficie del panqueque hay muchas burbujitas, entonces eso significa que está lista para voltearse del otro lado. En este caso vemos que ya hay 1, 2, 3, 4, 5, 6. Bueno, no les puedo contar, pero todavía le falta. Veamos. Ay, creo que ahora sí está lista para voltearse. Vamos a agarrar la sartén y nuestra espátula y con mucho cuidado vamos a voltear el panqueque. Bueno, me quedó bien. Y ahora vamos a esperar a que el otro lado se cocine. Para el verde, el mismo procedimiento. De nuevo vamos a poner la cantidad exacta de masa para pancake. Y ya tenemos la torre de pancake. Muy colorida. Y ahora le vamos a agregar miel natural, 100% natural. Luego le vamos a agregar una rica cebolla. Y ahora mi momento favorito. Es hora de probar. teacher and friends. I present my prototype is a water dispenser machine. My prototype has only one simple machine. To demonstrate how it works, it carries the screw and it used to hold it together. I use a small plastic bottle with a screw cap. The plastic cap and the bottle are held together. With the screw, the water stops from coming out. Open and close the bottle slowly to demonstrate how the water comes out. Thank you.
This is my wheel number 1. And this is
Good morning, teacher. My name is Annali Bonifati. The classroom for grade A. The name of my project, water dispenser machine. This is my prototype or working model of a water dispenser machine. Materials: a cardboard board, a small plastic bottle with a screw cap, glass reed, rubber, and advice tab. In a water dispenser, different simple machines are put together to make it work. That's why a water dispenser is a complex machine. My prototype has only one simple machine to demonstrate how it works. It's called the screw cap and used to hold things together. The plastic cap and the bottle are held together with the screw when the plastic cap and the bottle are held together. The water stops from coming up. Thank you.
Good morning, teacher. This is my science project. This is my prototype, water dispenser machine. A water dispenser is a complex machine because different simple machines put together to make it work. My prototype has only one simple machine, a screw, and hold things together. I use a small plastic bottle with a screw cap. The plastic cap and the bottle are held together by the screw, and when they are held together, water stops from coming out. Thank you.
materials used were a cardboard box, sticks, lids, cardboard, reeds, and balloons. I made this car by cutting the cardboard box, and then it made the shape of the car. In the hole I put the piece and the reeds and the balloon, and that's it. This machine works when you make air from tubes behind the car. The balloon above is filled with the cups, the tubes with your fingers, and then remove them and ready the car rolls. Here is a demonstration.
Hello teachers and friends, I present my science project, water dispenser machine. As you can see, my water dispenser works very well. Thank you.
Good morning, teacher and classmates. My name is Ana Lorena Castro, and I will present my complex machine, a water dispenser machine. The materials that I use: a big piece of foam, rhinestones, small plastic bottle, mini straw, and water. I cut the foam with my mom's help and paste it with hot glue. Later, I decorate with rhinestones and make a hole to put the straw on it. Finally, I fill up the bottle with water holding the straw, close the lid, and put it on the dispenser. I put clear window to see the level of the bottle. Thank you.
Okay, guys, I'm going to start with the water dispenser.
Wait.
No.
With the water dispenser, teacher.
I will start with the water dispenser machine. Okay, good. So what are you going to do? You already have the pieces, okay? Good. So first, you're going to put these 3 rectangles together. So how are you going to use it? You're going to put some glue. You're going to put some glue on the right side and the left side of the rectangle that it has the size of 20 by 9, the bigger one. And you're going to put some glue on the side, this side, but it needs to be inside, not outside. Why? Because once you put some glue here, you're gonna paste the one that is 20 by 8, you're gonna paste it like this. You're gonna paste it, you're gonna put it inside, okay, like this. Attention here, for the ones that are doing the water dispenser, once you finish with these 3 rectangles, you need to paste the bottom. So you're gonna use the one that it's 9 by 9, the one that it has no holes, no nothing. This is 9 by 9. So once you have this 3 together like this, once you have it like this, okay, you're going to paste it right here because this one is the bottom.
Good morning, teacher and class. My name is Jimmy Stephanie Lucero. I am in 4th grade C and I will present my project, Water Dispenser Machine. My prototype is a water dispenser machine. It's made with different materials that make simple machine that together make complex machine. My prototype have one simple machine, the screw that is used to hold things together. I use a small plastic bottle with a screw cap. The plastic bottle and the screw cap are held together by the screw. When I unscrew the bottle, the water comes out like this. Thank you.
Good morning, my name is Isaac Pinson. I am in the 4th grade C. Today I will present my science project, Balloon Powered Car. This is my prototype or working model of a balloon powered car. In a car, different simple machines are put together to make it work. That's why a car is a complex machine. My prototype has only one simple machine to demonstrate how it works, and it's called wheel and axle. I use 4 plastic caps for the wheel and a wooden stick as the axle. Turning the wheel, the axle turns. When the air comes out from the balloon through these straws, it makes the car move forward.
Good morning, teacher. My name is Jennifer. 4th grade C. Water dispenser machine. This is my prototype water dispenser machine. In a water dispenser, different simple machines are put together to make it work. That way, a water dispenser is a complex machine. My prototype has a simple machine. It's called the screw, and it used to hold things together. To make this a prototype, I use a small bottle with plastic cap and a plastic straw that be our screw. Then we put the plastic cap and the bottle are held together. The water is stopped from coming out by opening and closing the plastic cap. We can see how our glass is filled. Thank you.
Good morning, teacher and classmates. My name is Kilos and I am in 4th grade C. And I will present my prototype of We remove a finger from the straw and see how the prototype balloon power car moves forward while the balloon disinflates thanks to the force of the air. And this is my balloon power car prototype work. Thank you.
Good morning, teacher. My name is Ana Lucia Pinzon. I am in the 4th grade B, and today I will present my science project, the water dispenser machine. This is my prototype or working model of a water dispenser machine. In a water dispenser, different simple machines are put together to make it work. That's why a water dispenser is a complex machine. My prototype has only one simple machine to demonstrate how it works. It's called the screw and it's used to hold things together. I use a small plastic bottle with a screw cap. When the plastic cap and the bottle are held together, the water stops from coming out. Thank you.
Afternoon, teacher and classmates. Teacher, my name is Juan Diego La Rosa Rodriguez and I'm going to present my simple machine. My simple machine is a car, and the name is the wheel and the axle. How it works? It works because the axle is attached with the 4 wheels. And when I blow the balloon, it moves. And this is a demonstration.
Water released through with the straw, managing to administer the liquid to the glass.
Good morning, teacher and class. My name is Ana Jaramillo, 4th grade D. Today I present my project, water dispenser. For this project, I use a small plastic bottle with a screw cap, a cardboard, and a straw. How does it work? The plastic cap and the bottle are held together. When the plastic cap and the bottle are held together, the water stops from coming out. And finally, this is my result. Thank you.
Good morning,
teacher and class. My name is Leopoldo Quintero from 4th grade D, and I will present you this water dispenser and how it works. This water dispenser is made by recycled cardboard, plastic bottle, and a straw. How it works, I will explain you. When this bottle is closed, the empty pressure avoids force of gravity works. And when I open this bottle, empty pressure disappears and gravity force starts working. We will see an example. Okay, this is closing, and when I open this begins flowing. And when I close it, that is not flowing water. I will open it again. I close it. And this is how it works, this water dispenser made of cardboard. Thank you.
Good morning, teacher and classmates. My name is Nolan Sanchez. I am from 4th grade C, and I will present my science project water dispenser machine. This is my water dispenser machine. Here we can see my water dispenser machine complete. First, I used a small plastic bottle with a screw cap. I made a small hole in the bottom and placed a flexible plastic reed. I glued cardboard to make the base. Then I made again a small hole in a cardboard to put the reed. Finally, I put water in the bottle to make the science project function. Here we can see my science project work. And now it's ready to drink. Thank you.
Hello, teacher. This is my experiment. The title of my experiment is Soft Drinks and Soup. The objective is that we can separate solutions by just boiling them. The materials that we need are salted water, soda, regular water, 3 pots, and a wooden spoon. In this pot, we have salted water, and in the last pot, we have regular water. Let's see what's happened. Oh, look! In this pot, you can see that the salted water is boiling. And in the pot, you can see some sprinkles of salt. Isn't that interesting? Oh, look! Isn't this interesting? Because at the beginning of the video, we put a lot of water in that pot. But now, the water turned into gas because the water evaporated. See, in the second pot, if you see a little bit close here, like that looks like little freckles, but that's not freckles, that's sugar. The conclusion of the experiments is that water can change form. Like for example, this pot. In this pot, the water turned into gas. In this pot, we have salted water. The salted water turned into salt. And in the third pot, we have Coke. And the Coke turned into sugar. My recommendation.
Good morning, teacher and classmates. My name is Annabella and I will present the experiment sugar and soft drinks. For this experiment, I will use a pot of fresh water, a pot of salted water, and a pot of Coca-Cola. With the help of my grandmother, I will put the 3 pots in the stove. We have to wait until the water evaporates from the 3 pots. In the second part of the experiment, I will use a pot of Coca-Cola, a pot of orange juice, and a pot of Diet Coca-Cola. We also have to put the 3 pots with.
Good morning, teacher. I will present the experiment sugar and soft drinks. I going to add the water in the first pot. In the second pot. Now I am going to add the soda in the third pot. Mommy's gonna turn off the stove. I'm putting the salt in the pot.
soft drinks. The objective is to observe how much sugar exists in different kinds of soft drinks. The materials are 354 ml of salt water, 354 ml of fresh water, a can of soda 354 ml, 3 small or medium pots, and a wooden spoon. The procedure is I put the salt water in the first pot. I put the fresh water in the second pot. In the third pot, I put the Coke. I took photos of them at final the experiment. The results of the first part is the pot of salt water is evaporated, and in the bottom of the pot remains the salt. The pot with fresh water in the bottom of the pot remains minerals found in the water, such as magnesium, calcium, ferrous, and others. In the third pot, I put the soda Coca-Cola, and in the bottom of the pot remains something like a dark caramel. This experiment shows us that when the water evaporates, can remain substances that are dissolved in it. Thank you.
Good morning, teacher and friends. Today I'm going to talk about my experiment of sugar and soft drinks. Here we have normal soda strawberry. We have diet soda strawberry. And here we have juice orange. Now we're going to put the liquids on the pot. Now that my father turned on the stove, let's see what's happening. The liquids are boiling. Let's see how much sugar is in the juice. Let's see the diet soda. Let's see the regular soda. Here we have the results. The regular soda have a lot of sugar. The diet soda have a medium sugar, and the orange juice have a lot of sugar. Recommendation: please don't drink too much liquids with sugar. Bye. Hello, teacher and classmates. My name is Amani Maela Evans Stevens, and today I'm going to be doing an experiment about what are we really drinking. Part 1 of the experiment, we're gonna learn about how to separate mixtures. To do this, you'll need a can of your favorite soda, water, and salted water, and salt, and another bowl of water. Let's add us. Add
salt in one of our pots. With an adult supervision, we're going to turn on the stove. Wooden spoon, we're going to mix our soda, our salted water, and our normal. As you see, there's salt all over the stove, and we're going to mix a bit. All of that is salt on the edge. You see now that the soda is now sugar and our salt has turned, like it has evaporated all the water and the salt is right here. And the water evaporated all. Now you see, by boiling, now I learned something new, because that's how they get salt from the sea. For the second part, we're gonna be using 3 drinks, Diet Coke, normal Coke, and my favorite drink, which is apple juice. And we have our three pots that we're gonna put our drinks. Let's see what's gonna happen. So we're gonna need 3 pots and a wooden spoon. Okay, now we have our 3 pots heated up. Now we're gonna have an adult supervision and we're gonna pour our drinks. Now that we have our drinks all evaporated, we're now the amount of sugar. The Coke has it's black and it has a gummy consistency. The Diet Coke is dry and it doesn't have a consistency and it looks like a mark on a pot. And the apple juice is like, it's kind of yellow but orangey, and the consistency is like a gummy. The one with less sugar is the Diet Coke, because in the ingredients it didn't say any sugar. The one with more sugar is the Coke, because in the can it said it had sugar. The amount of sugar recommended daily is 6 teaspoons. We shouldn't drink too much soda or soft drinks that have too much sugar. And we should start drinking stuff like Diet Coke, because if you want like some a soda that's not too sugary, you can have Diet Coke, because it tastes just like normal Coke but no sugar.
Good morning, teacher and classmate. My name is Alvita Chigani and I am in the 4th grade. The title of the second experiment is Sugar and Soft Drinks. The objective is to know how much sugar we should eat and to avoid diseases. The materials I used are original Coca-Cola soda and without sugar, natural water, salt water, juice, and energy drink. For the experiment, we boil each drink to the point that all water evaporates to see how much sugar it had and other components. The drinks that have sugar are juice, gas sodas, and energy drink, and because it's composed by hydrogen and oxygen. Dilute because when extracting the liquid, dilute is extracted, leaving behind other components of the food when wanting to produce the amount of a glass. The juice and sugar of 3 oranges are extracted, thus concentrating much more sugar, and more sugar is added to make it sweeter on the palate. Yes, because it keeps our body healthy and we avoid diseases in the future. Nutritional recommend no more than 3% of calories a day should be sugar. This means that if we consume 2,000 of calories a day, of those calories, more than 200 calories must not be sugar. That equates to about 12 tablespoons of sugar per day, or 84 tablespoons of sugar in a week. In short term, the effects include trouble concentrating and mood swings from change in blood sugar levels. It also causes early and long-term and wrinkles, inflammation, weight gain, more serious hair diseases, and diabetes. Exercise daily, drink enough natural water, eat more fruits and vegetables.
Good morning, teacher. My name is Isaac Pinson. I am in the 4th grade C. Today I will present the experiment sugar and soft drinks. Objective: to observe the amount of sugar in soft drinks. To learn how sugar can cause health problems. Material: a wooden spoon, a can of Coke, water, salt water, a can of Diet Coke, a can of apple juice, and 3 pots. Procedure: place each drink in a pot and boil until evaporate. Results: each pot has a different amount of sugar, different color, and different consistency. The apple juice has more sugar and the Diet Coke has less sugar. Conclusions: the drink with less sugar is healthier, but the water is better. The nutritionists recommend in children consume between 30 to 35 grams of sugar per day. Consuming a lot of sugar causes hyperactivity and obesity problems. Recommendation: drink more water, do exercise, eat healthy. Thank you.
Good morning, teacher and classmates. My name is Nicole Quiroz. I for grade C. A title of the science experiment is Sugar and Soft Drink. The objective is to raise awareness of the consumption of sugar in our diet by measuring the amount of sugar in the drinks that we consume daily. The materials I use are natural water, apple juice, light flavoring, without sugar, original Coca-Cola, energy drinks. For the experiment, we will leave each drink to the point that all the water evaporates to see how much sugar it had and the another compound. As drinks that had sugar, where they use original Coca-Cola and the energy drinks. The others do not contain. No. The water, because it is composed of hydrogen and oxygen. The juice, because the fruit with which the juices are made already contain natural sugar, and when they are processed, artificial sugar are added to make them sweeter and more pleasant. Because the less sugar, the better for our body, because we avoid disease. Nutritionists recommended no more than 10% of calories should be sugar. This means that if 2,000 calories a day, of those calories, more than 200 calories must not be sugar. This equates to about 12 teaspoons of sugar per day, or 84 teaspoons of sugar in a week. In short time, the effects include trouble, concentrate, and mood swings from change in blood sugar levels. It also causes early and long-term anemia and willful inflammation, weight gain, and more severe heart disease and diabetes. Make 4 meals a day: breakfast, lunch, snack, and dinner. Include vegetables, fruits, legumes, cereals, dairy products, and meats. Perform moderate physical activity every day. Drink at least 2 liters of unsweetened water.
Buenos días, maestras y compañeros. Soy Melanie López del quinto B. Hoy les voy a presentar el experimento líquidos que no se juntan. Para materiales necesitamos el aceite, agua, miel y jabón. Primero agregamos el aceite, luego agregamos el agua, luego agregamos la miel, y luego agregamos el jabón. Como pueden observar, la miel es el líquido más pesado, por eso se va al fondo del frasco. ¿Por qué pasa esta reacción química? ¿Por qué no se mezclan estos líquidos? Porque tiene que ver con la estructura molecular de los líquidos. Si los extremos de las moléculas de un líquido son afines con los del otro, se alterarán, se mezclarán unas con otras, formando una mezcla como pasa con el alcohol y el agua. Hoy les voy a presentar el experimento volcán de lava. Materiales: carbonato de sodio, tinte color lava y vinagre. Añadimos el tinte en el vinagre. Primero agregamos el carbonato de sodio y luego agregamos el vinagre. ¿Por qué pasa esta reacción química? Cuando mezclas el vinagre y el carbonato de sodio, se crea una base de dióxido de carbono y el gas provoca las burbujas que salen por el cráter del volcán. Gracias.
Vamos a hacer los líquidos que no se mezclan. Vamos a echar un poquito de aceite de cocina. Echamos un poquito de agua. Y como verán, no se mezcla. El agua se queda abajo y el aceite se queda arriba. Ahora echamos un poco de miel La miel se quedará abajo. Y por último, jabón de manos, líquido. Y así tenemos los líquidos que no se mezclan.
Hi, my name is Dylan Barres from the 6th grade C, and I'm going to make the experiment, the foam machine, show a chemical change. A chemical change is any change that causes a new substance to be formed. My experiment is a foam machine. There are carbon dioxide. Is it the new substance produced by the reaction, and it combines with a swap and produces foam and flow out the glass.
You will need 2 similar shaped glasses, teaspoon, power detergent, 2 stirrers, vinegar, baking soda, and water. Step 1. Place half teaspoon power detergent into a glass A and fill it 1/3 with a vinegar and then stir gently. Step 2. Place 1/2 teaspoon baking soda into glass B and fill it 1/3 full with water and then stir gently. Then I use a large container to put the contents of a glass A, then the content of the glass B, and see all the foam forming. I have made more of the mixes because I want to see in the foam flow all over.
Good morning, my name is Sara Serrano, and today I'm going to talk about my project known as slime diagnostics in the hand. The materials are white rubber, shaving cream, detergent, liquid for contact lenses, baking soda, glue sponge, and highlighter. Also, we need a container. The first thing that we're going to do is to put the glue in the container. Then we add the baking soda. Now we take the highlighter and open it and pour this liquid that is inside. After we do this, we add the shaving cream. Now we add the liquid for contact lens. And with this, we have our slime that can stick in the hand. In conclusion, we can say that mixing the liquid for contact lens and the baking soda makes for slime not stick in any surface. Thank you.
Good afternoon, teacher. My name is Lian, and I'm going to present you the experiment creation of carbon dioxide from the combination of vinegar and baking soda. For this experiment, we will need vinegar, a bottle, baking soda, a funnel, and a balloon. For the second part, we will need a glass, a lighter, a spoon, and a candle. First, we put the vinegar in the bottle. Then we put the funnel in the balloon and put the baking soda. And next, we put the neck of the balloon around the edge of the funnel. And then we let the baking soda pop. And as you can see, the balloon starts to inflate. This means that we are creating a gas. But which gas is the one we are creating? Carbon dioxide was the gas that was created on the first part of the experiment. Now we're going to prove that the gas that was created is carbon dioxide. Do you know that carbon dioxide is often used in some fire extinguishers? The important thing here is that the carbon dioxide is heavier than air, so it will stay on the top of the bottle, but you can see it. Now we're going to test it by using it as a fire extinguisher. I will take the bottle and pour the gas on the top of the candles very slowly. Then you will see that the candles will go out. This happens because the fire needs oxygen to stay, and when we pour the carbon dioxide, it immediately replaces the oxygen. I hope you liked my experiment. Thank you.
Good morning, teacher and classmates. My name is Ambar Jaén, and today I'm going to present my chemical change experiment. The ingredients that we're gonna need for this experiment will be purple cabbage, water, vinegar, lemon juice, kitchen cleaner, alcohol, and baking soda, along with extra glass for reference. In a blender, put the purple cabbage to obtain the juice extract of this. To this, add a little water. Once finished, proceed to strain it in a colander. Then we will proceed to mix the cabbage with the following substance, and you can see the next color change. The first thing that we have to know is that there are substances called acids and bases. Acids are substances that when dissolved in water produce hydrogen dashes. The bases dissolving in water produce dashes of or H-bond dashes of hydrotoil. These two are common substances that we can find in our daily life. Some examples of acids are citrus fruits, or also known as acetic acid, found in vinegar. Some everyday bases are sodium bicarbonate or sodium hydroxide. The way we measure how acid or basic is due to the pH. Acid substances have a pH lower than 7, and base substances have a pH greater than 7. The purple cabbage has a type of substance that is known as anthocyanins. These are compounds that we can find in flowers, vegetables, fruits, such as purple cabbage, Jamaica flower, or beets, and these are the cause of the colors that we find. This substance changes its structure when it is with an acid or a base. For example, pH less than 2.6 tend to a red color. When we are at a pH greater than 7, they tend to change to a purple color. Due to this, we can see the amount of colors in our project. Thank you.
Good morning, teacher Samantha and friends. Today I am going to present my project chemical chain. The chemical chain is a chain that creates a new type of matter with a different property. Sometimes, when a different things are mixed together, a new substance is produced. Today I am going to bake a cake to prove it. We need water, oil, eggs, and cake mix. I am going to mix the ingredients in a bowl.
Cake mix. Water, oil, and eggs.
The ingredients and beat, you can see how another substance is create complete difference. Then put in an oven for 20 minutes. You have a new substance. The result is a cake that has a property that differs from the property of the ingredients. First, change the color, smoke the smell, and the cake is baking. And now enjoy the baking. Thanks.
Good morning, teacher and friends. In my experiment, I will show you the banana's chemical changes process. To see this process, we will put the banana over the ground and evaluate the chemical changes day by day. The changes I will record in pictures with these two cameras. We will open part of the banana so we can see the fruit. Day 1, we can see a slight change in the fruit, color and shell. Day 2, we can see that the fruit is starting to get dark and soft. Day 3, we can see the increase of the composition and change the color turning black. Day 4, the fruit oxidation continues and you can see some bees and bugs eating from it. Day 5, the banana shows an advanced chemical changes. At the end of the chemical changes, we can see the banana have an advanced degradation, and also we can see the mushrooms under it. The banana will become an organic compost, and it will fertilize the ground to have a strong plant. Thank you.
Buenos días, mi nombre es Chelsea Machisi, soy el sexto C y vengo a presentar mi experimento para la Semana de la Ciencia. Mi experimento trata sobre pintar una flor blanca de color. Los ingredientes son colorante vegetal, agua y una flor blanca. El primer paso es vertir agua en un vaso. Proseguiremos a echar colorante vegetal en el agua, el color que uno quiera. Después de esto, a la flor blanca le cortaremos el tallo en una forma que el tallo esté abierto para que el color reaccione. Luego pondremos las flores adentro del agua y lo dejaremos reposar por 1, 2 o 3 días para que la flor se vaya. ¿Por qué ocurre esto? Esto ocurre porque en el momento de hacerle el corte al tallo, él absorbe el agua con color y lo manda hacia los pétalos. Por esto las flores se pintan.
Muy buenos días, maestros y compañeros. Mi nombre es Vina Yetman y hoy les voy a presentar mi experimento sobre la tercera ley de Newton, que explica cómo funciona un cohete. Materiales: vinagre que está dentro de la botella, una botella plástica decorada en forma de cohete, una pastilla de servilleta y adentro tiene bicarbonato de sodio y un corcho. Lo primero que vamos a hacer va a ser meter la pastilla en la botella, dejando este extremo del hilo afuera. Se le mete el corcho y se bate. Esto pasó por lo que dice la ley de Newton. La ley de Newton dice que cada elemento, que cada acción tiene una reacción. Y la acción de esto fue que la combinación de vinagre con bicarbonato hizo una mezcla que expulsó para arriba, y como el corcho estaba solo puesto, sacó el corcho y el cohete voló. Muchas gracias.
Hola, soy Camila Rocha del sexto A y he decidido confeccionar una bomba de agua. Para eso requeriré los siguientes materiales: un motor DC, conectores, un lapicero, marcador, tijeras, algunas tapas, batería de 9 voltios, pegamento y un extracto. Ahora sí, comencemos. Como pueden observar, mi proyecto es totalmente funcional. Funciona de maravilla. Esto le puede servir a ganaderos, agricultores, granjeros en la época de verano.
Buenos días, maestros y compañeros, soy María Ángel Camp del sexto C y el día de hoy vamos a estar haciendo un arcoíris líquido. Nuestros materiales son agua, un frasco grande y un frasco pequeño, aceite, colorantes rojo, amarillo y azul, miel, alcohol y jabón para fregar de color azul. Para empezar con nuestra base vamos a hacer el color morado. Para hacerlo vamos a necesitar miel, colorante azul y colorante rojo. Y lo mezclamos. Ahora, para continuar, vamos a utilizar el detergente para fregar de color azul, y para que este proyecto quede bien hecho tenemos que verter cada material con mucho cuidado. Ahora vamos a continuar con el color verde. Para el color verde vamos a utilizar agua y hay dos opciones para colorar el agua. La primera opción es utilizar colorante amarillo y colorante azul. Y la segunda opción es utilizar bebida en polvo de color verde. Ahora vamos a hacer el color amarillo. Para el color amarillo nada más vamos a tener que utilizar aceite. Ahora, para nuestro último color, vamos a utilizar el alcohol y tanto pintura como colorante para que nos quede un rojo bien intenso. Vamos a colocar el alcohol y nuestro colorante. Ahora ya tenemos aquí nuestro arco iris líquido. La razón por la cual nuestros materiales no se mezclan entre sí es debido a que cada uno tiene más densidad que el otro. La miel tiene más densidad que el jabón tiene más densidad que el agua tiene más densidad que el aceite y el aceite tiene más densidad que el alcohol. Muchas gracias.
Hola, mi nombre es Vina Yetman del sexto C y les voy a presentar mi proyecto de absorción para la Semana de la Ciencia. Absorción es la retención de la sustancia por las moléculas que posee otra, bien sea estado líquido o gaseoso. Los palillos de dientes están hechos de madera deshidratada. Vamos a usar la propiedad de absorción de la madera y la propiedad de obtención de la superficie de agua para realizar este experimento.
Vamos a necesitar un gotero, una vasija, 5 palillos y agua. Empecemos con el experimento.
Paso 1. Partimos los palillos a la mitad sin separarlos del todo. Paso 2. Sobre un plato o bandeja colocamos los palillos bien juntos haciendo la forma de una estrella. Paso 3. Colocamos un poco de agua con un gotero en el medio de nuestra estrella con mucho cuidado. La madera, que es muy porosa, va a absorber el agua de manera que los palillos se hinchan y van a agrandar nuestra estrella poco a poco.